Hi, very good morning to you. It's Jim from maverickstar Observatory. Guys, we're doing a latest magnetic pole positioning for you today. I know some of you can already see it's advanced westerly again, but we'll get into it in a little bit. I just wanted to say a big thanks to those people that realised that over the last few months things have got a little bit difficult here at the observatory in raising funds, and that's because we've had a few regular supporters that used to support us every month. They've had to, because of the personal circumstances, drop off, and maybe at a later date they might come back when things improve. But we've noticed, not just from any particular one country, we've noticed a slowdown of funds in general from countries all around the world. And that means that the problem is global, economically. But we're still here. We're still doing, the latest magnetic pole positioning for you. We're trying to do it still twice a month. It would be, enormously appreciated if we could do a little bit better on raising some funds for the channel, because we still do, if not more work now than we did, say 6 months ago when we was just doing the positioning once a month. As you can see, the pole has migrated 1.56 miles, and that means it's now left the pack of where it was loitering for a few months. You can see it's gone now, past even the position that we had on the 2nd of the 7th this year. And we witnessed again it go backwards. It did seem to hang around a lot longer this time when it went backwards, but now it's definitely tracking west again. So it's back on. The magnetic North Pole is still tracking as we speak right now, even though it's a slow pace. Doesn't seem a lot, in 17 or 18 days or thereabouts. 1.56 miles is not a lot, but that's still an acceleration. When we go back to the 2nd February this year, this is showing, still a progressive heading towards the west. We know why it's going there, because of Russia's high intensity there is drawing the pole, or the dipole, over towards central Russia, and the reason why it's winning it away from Canada, where it was 100 years ago, is because Canada's magnetic intensity over that continent is weakening. We've got a muon detector over there. We have got one which seems to be a little bit redundant in Perth, Australia. Jeff's one there. We've also got a magnetometer there. We haven't had any data there for quite some time. Likewise with the one from Scott in Arizona. But let's see if we can get on the phone over the next few days and see if they've got any data for us, and we can update the website with regards to those two other locations. I have got some data I've got to process from Kendall in Canada, and I know he regularly sends his muon data. And then why we're studying the muons is because when you have a weakened magnetosphere, you will get more muons at ground surface levels, because muons are subatomic particles that have been smashed high up in our atmosphere by interactions with atmospheric particles like oxygen, nitrogen, those very common particles that are in our atmosphere, or those gases that are in our atmosphere. And when cosmic rays hit these particles, they smash them to bits, and one of the byproducts of a smashed particle is a muon. And we're very lucky to have muon detectors here at the observatory. And one thing I want to do over the next month or so is build a couple more and get those out to other locations. We're going to try again to get one in Russia along with a magnetometer, and also, we've been talking about it for a long time. It is past time now. We had one in either Brazil or Chile, or even at the worst South Africa, because the South Atlantic anomaly is currently splitting into two over the South Atlantic Ocean, and it is now well covering South Africa. So if we could get another muon detector there, another magnetometer there, we get more data, and it couldn't be any better than that. getting it from the South Atlantic anomaly, because that is the lowest magnetic intensity on our planet. The highest magnetic intensity on our planet is over Russia. But, with current, things going on over there with Ukraine and the West at the moment, it is sort of understandable why, people would be, reluctant to trust taking equipment from the UK to Russia and regularly sending us that data back, because of two reasons. It could, one, for be seen as spying, and two, they could get in a lot of trouble for that. So I understand, but we still must try, if we want to, cover the best aspects of our planet. So, as you guys know, we've got the TriMag system here in the UK, along with the muon detector and a magnetometer, which measures the magneto intensity over this region. And, we regularly update the website. The reason why I started to study this a long time ago is because I was one of a few people that would regularly go onto NASA's website, and I would look at LASCO images, video images, and stereo A, stereo B, and was always fascinated by the solar flares and things like that. And we did a few times, if people remember, going back some years now, predict accurately a few times, solar X-class flares. And these are the bigger X-class flares, or the bigger CMEs that come off the sun. And if they are Earth-facing, directional, as they travel out, they do glance Earth's magnetosphere, and of course they can cause severe electrical issues with any electronics. And we've had some incidences which haven't been recorded that I think they kept it a little quiet because they didn't want the panic to erupt in the media. But there was, I'm not going to mention a particular aircraft that was in manufacture, and they had to make more redundant avionics on that aircraft because of one of the events that took place, and that was a CCU strike on the main board, which affected the electronics on that plane and made it, for briefly, just a few seconds, do some pretty unusual and unwanted things. And of course, after analysing what had took place, they then introduced the new avionics on that aircraft, and as far as I'm aware, they haven't had any severe problems. But these are, the sort of problems that can affect us and our electronics, even at surface levels. Now, you do get more radiation at 40,000 feet. That's already been proven. But you also do get, these radiation events, not just in the atmosphere, but on the surface as well. And what we're particularly looking for are like I said, the smashed particles that happen in our upper atmosphere with atmospheric gases involving collisions with cosmic rays. So, guys, I will mention the link here at the end of the video this time. If you want to help us, it would be greatly appreciated. We're going to try and do our best to keep informing you of this rare anomaly. And I didn't get to the point, did I? Let me just get to briefly the point. The reason why I started to study the magnetic pole, it was because it was the only abnormally behaving anomaly that is taking place on our planet. Some people say, we're getting more volcanic eruptions than we ever have done. It's not true. And they also say that the magnitude and intensity of earthquakes are increasing. And of course, there is no real evidence of that either. There are more extreme climatic events taking place on our planet, and that could be due to the fact that our magnetosphere has weakened to around about 20 to 25% at the moment. And of course, as a result of that, we get cosmic rays interfering with our jet streams, as we've pointed out many times on these videos that we've done for you guys. So, you know, over the next coming days, we'll do an Earth Elf at a glance. We'll look at the latest earthquake, highest magnitude over the last 24 hours. We'll have a look at the volcanoes in eruption. And instead of just showing you all the data, let's actually have a look at some images and make it a little bit more interesting for you. So I hope you want to still be part of our supporters. There's a link down there if you want to help, and it would be greatly appreciated, as we are in these times at the moment of difficulties, let's just say that. Okay guys, much love as always. Take care of your loved ones. Bye for now.